Hello, welcome back to Algebra. The title of this lesson is The FOIL Method of Multiplying Binomials Explained. And I want to make sure and explain to you whenever I get really excited about teaching a lesson. I love teaching all this stuff, but a few things poke out to me, and this is one of them. Because I remember learning how to multiply binomials. You know, 2 terms times 2 terms. That's multiplying 2 binomials together. And I learned something that you're going to learn in your class, and it's called the FOIL, F-O-I-L, the FOIL method of multiplying binomials. And you're taught that in every algebra class. It's the way that we multiply binomials together. But almost no teacher actually explains to you why we multiply binomials using that FOIL method. And I really don't like that because it tells you that, hey, you have to memorize all these things that your teacher says, and you just do it that way, and there's no reason, just do it that way. It's just the way it is. Well, the truth is, the FOIL method of multiplication makes sense. And I'm going to show you what the FOIL method of multiplication is, what multiplying binomials really entails, and why we use that method and why we use those letters. So at the end of this lesson, you should understand how to multiply using FOIL and why we do it that way. And in the next 2 lessons, we'll be getting more practice, two more detailed lessons of more complicated problems to give you practice multiplying binomials together. So before we go any further, I want to recall, or have you recall, something that we learned in the past, because it turns out that multiplying binomials is related to what we've already done in the past. What if you have x times something very simple, x plus 2? How do you do this? So you learned a long time ago that when you have a term wrapped in parentheses, or 2 terms in this case, a binomial, this is a binomial by the way, 2 terms in parentheses, and you have something on the outside, this is a monomial, then what you do is you take what's on the outside, you multiply it times this term, and you multiply it times the other term, and then you write them out. So what you're going to get is x times x is going to give you x squared, and then x times 2 is going to give you 2x. And the reason there's a plus sign here is because there's a plus sign here. Positive 1x times positive 2 will give you the positive 2x. Now notice here that in your final answer, there were actually 2 terms in answer. Right? 2 terms. This is number 1 and number 2. And that'll become interesting later on. I'll talk to you about it. So the critical thing to remember about multiplying anything in algebra is when you have a parentheses, a set of parentheses, with, in this case, we had 2 terms inside. But actually, it can have any number of terms inside the parentheses, right? Then if you have something sitting right outside that parentheses, then you know from the rule of distribution that in order to do all the multiplication, you have to take that outside term and multiply it times every term on the inside, because if you only multiply it by half the terms, then you've only done half the multiplication. That term inside the parentheses consists of 2 things. So in order to do the complete multiplication, the outside thing has to affect everything on the inside. Otherwise, you've only done half of the multiplication. All right, so anyway, you've done it via distribution. Now, let's go and let's change it a little bit. Let's change this to the following thing. Let's change it so that you have, on the outside, instead of x, you actually have a parentheses with something like x plus y. And on the other parentheses, you have x plus 2. Now, for some reason, and I was the same way when I learned this, when a student sees this, your brain starts to go berserk and you have no idea, like, whoa, the alarm bells start going off and all of that. But when you think about it, what's going on here is you're still multiplying something by x plus 2, just like you were doing here. And you know how to handle this. You take the x times this and the x times this and you add them together, right? But now, instead of multiplying by a single thing on the outside, we're just simply multiplying by 2 things linked together with a plus sign. So in order to do a complete multiplication of this times this, the way you handle it is as follows. This first guy on the outside has to multiply into the x, and then this first guy also has to multiply into the 2. Because basically you just pretend the y is not even there at all. If there were just an x out there, then you would just do whoop, just like this, multiply times each interior term. So let's write those down. If you just multiplied x times x, you would get x squared. And if you just multiplied x times the 2, you would get the 2x. Okay, great. But you can't stop there because obviously you have something else out here. If you were to cover up the x, and if you were only multiplying by y, you would multiply y times also each interior term, which would be y times x. You could call it yx, but I'm going to call it xy, just because I like to write it that way instead. And then y times 2 is going to be 2y. And notice that what you've done when you've done this here is there are now no longer 2 terms in the answer, there are 4 terms in the answer. Right? The reason that there are 4 terms is because you're multiplying 2 terms on the inside of something times 2 terms on the outside of something, and in order to get a complete multiplication, you have to multiply every term on the outside times every term on the inside. And then on the other term, every term on the outside here times every term on the inside. So because there's 2 terms in both places, you get 4 terms in the answer, right? So this is actually the answer to this multiplication. We haven't talked about FOIL yet. I'm going to get to that later. Don't worry about it right now. For now, I want you to know that whenever you're multiplying this times a binomial, you just take the outside guy. It has to be distributed to each term on the inside. In fact, what I usually do is I remind you of that by drawing an arrow here to say we're multiplying that times that, and then we're multiplying that times that. And on the bottom, I'll draw an arrow here showing you that I'm multiplying the y also by both terms. That's why you get 4 terms. So these 2 come from the first 2 multiplications of this one, and the last 2 come from these 2 multiplications of that one. That, in a nutshell, is how you multiply 2 binomials together. 2 binomials together. Now, I'm going to give you a little bit of a preview. I don't want to get into the details of it right now. I'm going to get into it in a few lessons, but I want to give you a preview. What do you think you would do if what you were multiplying on the outside did not have 2 terms? What do you think you would do if there was a 3rd term out here, like x plus y plus z all out here? Well, you would have x times these 2 terms, and then you would have y times these 2 terms, and then you have z times those 2 terms, and then you would add them all together. So there wouldn't be 4 terms in the answer, there would actually be 6, because you'd have 3 times 2, and that would give you 6. So you see why I like to teach it this way, because I'm showing you logically how what we're doing is a direct result of what you've already done with distributing regular terms. So now you can multiply this, and you know what's happening. You're distributing each term, and then later on, if I give you a much, much more complicated expression, then you can just do it because you know that every term has to go in and multiply by every other term. So then, let's take another example. We're going to fly through a few examples now to give you a little more practice. What if I have x plus 6 multiplied by x plus 4? Well, it's the same kind of thing. I have to take the x and multiply it by the first term, and then I have to take the x and multiply it by the second term, which is going to give me what? X times x gives me x squared. X times 4 gives me 4x. We generally write the number first. And then I'm going to have this secondary term multiplied in by each of these as well. 6 times x is 6x, and 6 times 4 is 24. Now notice I got 4 terms here, just like I did here. The only difference is when I look at this, I realize I have a 4x and I have a 6x. So actually I can combine these 2 and add them because they're like terms. So I'll have x squared plus, this will be 10x, plus 24, and that will be the final answer, x squared plus 10x plus 24. All right, want to do, let's do one more on the next, let's do a few more on the next board, and then we'll talk a little bit about FOIL. All right, so then for the next one, just to get some more practice, y plus 7 multiplied by y minus 3. So you pretend the 7 isn't here at all, and you just now, I'm going to stop drawing my arrows for every problem. This will probably be the last one that I do. But this y needs to be multiplied by each term on the inside, distributed in, as you would guess. So then what we're going to have is y times y is going to give you y squared. Y times a negative 3 is going to give you negative 3y. But then after you're done with that, to complete the multiplication, the 7 has to be multiplied here, and it also has to be multiplied by there as well. So what is 7 times y? It's 7y. What is 7 times negative 3? That's negative 21. Then I say I'm done with 4 terms. However, I can add these together. They're like terms. So I'll have y squared. What is negative 3 plus plus a positive 7 is plus 4y. And then I'll have a minus 21 here on the end. Y squared plus 4y minus 21. That's the final answer to that problem. All right, let's take it a little bit more complicated, just a notch. Not too bad though. What if we had 3x plus 1 multiplied by 2x plus 5. So it's going to be the same thing. The only difference is the first term here actually is 3 times a variable. The first term here is 2 times a variable. And in fact, all the other problems, we just had single variables and single digit things everywhere, but exactly the same thing applies. We have to take this 3x and we have to multiply it times both of those guys over on the other side. So what is 3 times 2? It's going to be 6. And what is x times x? You add the exponents, giving you x squared. Now you have to take this and multiply and distribute into the other guy, which is 5. 3 times 5 is 15. And the x is still multiplied, 3x times 5, so it's 15x. Then we'll take the 1 times the 2x, giving you 2x. And we'll take the 1 times the 5, giving you a 5. And then we realize we can combine these like terms, so we'll have 6x squared. What is 15 plus 2? It's 17x, and then the 5 comes along for the ride. So 6x squared plus 17x plus 5. All right, so what I want to do is, first of all, call your attention to the fact that we talked about how to multiply these binomials together using nothing more than an extension of what you already know, how to distribute things on the outside. And now you know that when you have 2 terms linked together, then they have to be each multiplied by everything, each distributed in to the following term. Now let's zoom in to one of these examples a little closer, this one here, the x plus 6 and the x plus 4. I'm going to do that on the other board, and we're going to talk a little bit about FOIL, and you're going to see the punchline is that the FOIL method of multiplication, which they teach you in class without telling you what it's for, is exactly what we've just done here. So you're really learning nothing new. Let's examine one of these a little bit further. Let's say we have x plus 6 multiplied by x plus 4. So I'm choosing this one because we've already done it before. So the x times the x, let me go ahead and, for this one case, I'm going to go ahead and do this, draw my little arrows because I'm going to be coming up that direction. I'm going to do a different color for the bottom ones, like this. So when we do the first guy, x times x will give me x squared. And then 6 times, x times the other guy over here will be 4x. X times 4 is 4x. Then we have the 6, the second term, times x will give you 6x. And then the 6 times 4 is 24. Let me just double check I didn't make any silly mistakes so far. All right, notice what we've done. I've explained it to you as distributing in from the outside, which is all correct. But notice that there's an easy way to remember this for people that don't learn it what I consider to be the right way, is that the first thing that we multiplied together is the first terms. In other words, this is the binomial and this is another binomial. These are the first terms. The x and the x are what we call the first terms because this is the first term of this one and this is the first term of this one, right? So this guy, I'll go ahead and draw it out here. This is called first terms. And that was x times x, right? And so because it's first terms, we're going to put an f there. And then after that, we multiplied x times 4, but this is the outside terms, right? So these are the first terms of each guy. This x times the 4, these are the outside terms. They're on the outside most part of the parentheses. So this guy here is what we call outside terms. So we call that O, and that was 4 times x. All right. Then notice that we multiplied the 6 times the x. These are the inner terms, the most inside most terms. So we label this inside terms, 6 times x, and we call that capital I. And then these are the last terms in each of the 2 binomials, 6 times 4. So we label that the last terms. And it was 6 times 4, and it was last. So this is the famous FOIL method of multiplication. First, outside, inner, last. Typically, what most algebra books are going to do is they're going to say, hey, when you're multiplying 2 binomials together, like, you know, in this case, it's x plus 4 and x plus 6. When you're multiplying 2 binomials together, follow this recipe called the FOIL method. FOIL means first, O means outside, I means inner, and L means last. So the first terms are these two terms, the outer terms are these two terms, the inner terms are these two terms, and the last terms are these two terms. And all you have to do is first multiply the first terms together, giving you this, the outside terms together, giving you this, the inside terms together, giving you this, and the last terms together, giving you this. So it's first, outside, inner, last. And you follow it like a cookbook. First, outer, inner, last. First, outer, inner, last. And it works every single time because you write your first, outer, inner, last multiplications, then you add these together, and you get the answer, and it's great. There's nothing wrong with using the FOIL method. In fact, as we work more problems in the next few lessons, I'll probably refer to the FOIL method subconsciously because I learned it myself when I learned algebra. So why am I harping on it? Why didn't I just open this lesson up and say, hey, there's something called the FOIL method, you have to use it? It's because it doesn't help you if any problems exist beyond multiplying binomials together. It doesn't help you for any more complicated type of situations. Let me give you an example. Before we get there, let's do one more, as we now know that this is called the FOIL method. Let's take a look at 2x minus 3 times x plus 8. All right, so I've been teaching you just to distribute things in, and that's fine. It's exactly what we've been doing, but you could also just think of the FOIL method. Hey, here's the first terms, 2x times x, that's 2x squared. The outer terms will be, this is an outer and this is an outer. 2 times 8 is 16, so you get 16x. The inner terms will be negative 3 times x, you have a negative 3x. And the last terms would be this one here, negative 3 times 8 is negative 24. And then you can add these, so you get 2x squared. What do you get? 16 minus 3 would give you 13x minus 24. Let me just double check them right before I continue on. Yeah, that's the right answer. So you see we did first multiplications, then outer, then inner, then last, which is the exact sequence that I taught you initially. In other words, the FOIL method is exactly what I already told you. The first terms is when you distribute this in. The outside terms is when you distribute this in. The inner terms is when you distribute this in. The last terms is when you distribute that in. So why am I making such a big deal out of it? It's because people memorize this recipe, first, outer, inner, last, but they have no idea why it works. So then, later down the road in algebra, maybe I give you this. Maybe I give you, which we will get to, 2x squared plus 3x plus 2 times x minus 1. You see, if you've learned the FOIL method, first, outer, inner, last, first, outer, inner, last, then you have no idea how to multiply this. What's the first terms? What's the outer, inner, and last terms? How do I do it? You have no idea how to handle anything beyond this cookie cutter recipe if you just memorize a cookie cutter recipe. But hopefully now you all realize that there's no magic behind how you multiply this together. What you do is you realize this term has to be distributed into each of these, like this. Right? Then this term needs to be distributed in to each of those terms, like this. Then that last term, which is kind of hard to show without getting in the way here, has to be distributed in as well, right? So even though we're getting a little bit ahead of myself, I think it's really important for you to see 2x squared times x will give you 2x to the third power because you're going to have an adding of the exponents. Then 2x squared times minus 1 will give you minus 2x squared, because negative 1 times that's 2x squared. Then you move to this term, and it has to go into each one as well. 3x times x is 3x squared, because x times x, you add the exponents. Then 3x times negative 1 will give you negative 3x, right? Then you go to this one, which has to be distributed in. 2 times x is 2x. And then 2 times negative 1 is, I'll have to write it on the bottom, unfortunately. Yeah, I'll do it here, negative 2. Like this. So you see what's happening? You have now 1, 2, 3, 4, 5, 6 terms, because this one goes boom, boom, this one goes boom, boom, this one goes boom, boom, and you don't ever talk about FOIL because it doesn't matter. And then if I give you another problem where this one has 3 terms, then you know how to do the same thing, and it works for any multiplication of any polynomials, which we're going to get to a little later. This is a little bit of a preview. Of course, I can simplify this by adding these terms. I can simplify this by adding those terms. I'm not going to do it now because this isn't the point of the lesson. The point of this lesson is that we're learning something called the FOIL method, first, outer, inner, last. But it's not a magic recipe. It's developed because we multiply binomials by distributing every term into every other term. So what we're going to do now is make sure that you understand all of these, copy all these problems down, solve them yourself, and then follow me on to the next lesson where we will continue multiplying binomials and getting practice using this FOIL method of multiplication, which really is just distributing terms in disguise.